values, so k should go from 0 to infinity. Okay, so that is the definition. Any questions? Then of course we need to calculate this. I did some trial and error, I remember, when I was solving this problem. But what is a good point? If you compare this sigma in the definition with what you want to achieve, they are similar except that I have n greater than k here rather than n equals to k. Of course, that is the price I have to pay if I want to add these things here. I don't know, might be you start manipulating the left-hand side and be able to go to the right-hand side. But that is important how? Do you have any idea? I remember I did some trial and error and I realized that I was not thinking properly, because might be a good idea is to get rid of this guy and somehow bring this inequality into the problem. Okay, so might be that's a good idea to continue with. So if I want to do that, then can you see that I can write something like this? Can you help me to write it, at least at that intuitive level? How can I write the P of n equals to k in terms of probability in which n is greater than k or something else, which becomes closer to what I want to reach? So this means that the probability that n exactly picks up the value k, but if I want to have the same probability, but I want to change the equality sign to greater than sign. Yes?
Would it be the sum from k to infinity?
No, if it is equal to k.
No, but if we want to make it equal to, or
no, I'm asking you, write something here, write this as the probability in which I see greater than sign rather than equality sign. Yes?
Or minus the probability that n is greater than k minus the probability that n is less than k.
Yeah, that's a good idea, but I started with that idea, but in principle it will not work because it brings this with negative sign. Yes. So yes, but you are right, that was my first try, okay? And it didn't work. But then I realized might be it is good. I want first of all, do you agree with what I'm writing here now? If it is plausible, you're okay, otherwise I have to justify it. So this means that n, what are the chances for n to take here? Greater than k minus 1. So it starts with k, k plus 1, k plus 2, etc. But this tells you it starts with k plus 1, k plus 2, etc. So if I subtract them, it becomes p equals to n equals to k exactly. Okay, so if you don't like it, how can I really justify this? Because if I have this set, n greater than k minus 1 as my set, so it will be which set? The set of these values, yes, k, k plus 1, k plus 2, etc. But when I say n greater than k means what? Means k plus 1, k plus 2, etc. But I hope that if I call this a, and if I call this b, and if I calculate a minus b, what will happen? It means the elements which are in a but not in b, there is only one of these things, so it becomes this single element k. Yes? And if I want to calculate p of a minus b, do you remember? It becomes the formula in the beginning we had. It was p of a. We proved this using the axioms. Minus, do you remember? A intersect b. That is one of the theorems or problems we solved back then. And then if I ask you what is p of, so a minus b is exactly this. Yes, and p of a is this one, which can be written in this form. Minus. What is the intersection between them? A intersection between them becomes B itself. Yes, so then it becomes P of B. Yes. So that is my justification. So if you don't like it, of course at the intuitive level it is clear, but if you want to have it more precise, you can use these axioms. But anyway, is that understandable? Okay, but what is the benefit of that? So I can continue. So I can write sigma. Hopefully that 1 does not impose any problems, you know. Let me start with 0. Otherwise I have to separate 0 and continue with 1. That would be safer. But let us stick for a while. So don't write it down. So I will not accept responsibility if you want to cross it over. Okay. So P of n equals to k, I have to write this instead. Yes? Okay, and then I open it up as 2 sigmas. You have completely enough experience how to manipulate, engineer these sums. Yes?
You can shift it because and it's the
So shift it to what? To make it k?
yeah, like you start the sum with equals 1 perhaps.
So if you increase, then you have to subtract.
Okay.
So you have to do it the other way around. Yes? So for the sigma level, I don't think it's a problem. So one thing you can do, yes, let us do that. I want to make this very similar to that one. So if you don't mind, because this is k minus 1. So first let me fix this one to make it k1 minus 1, which is possible. I pull 1t out. Yes. And then let me, for the time being, copy and paste this one. Okay, but now the good news is that at least they are of the same type. So now whatever I do to fix this k minus 1 to k will also fix this one. So that is good. But in order to fix this one, I have to add 1 unit to k. So it means that I have to subtract 1 unit from k here. So then it becomes what? Then it becomes sigma, t sigma. K goes from minus 1 up to infinity. And then it becomes t to power k, p greater than n greater than k, and then I have minus sigma, k goes from 0 to infinity, and then I have t to the k, p n greater than k. Yes, do you agree? And then I hope that you are not feeling bad about having k equals to minus 1. Do you have a bad feeling about it? Because I have written that the values are 0, but this is not probability here. I'm just manipulating the sums. Okay, so k for me is just an index. What I am doing, I am claiming this sum, whatever it is equal to that sum, even though the price that I have to pay is to start from minus 1. So don't think because this is from 0 that is not acceptable. So do you understand that? Is it not confusing? You have to say something, okay? Yes or no? Is it confusing or not? Okay, so what should I do now? Okay, so now, but this is a problem now. What is that problem now? The problem is that I want to have only this combination, okay? But that should be a small fix. Yes, what can I do? It starts from minus 1, but I want to have it starting from 0. So what is the price that I have to pay? Is to put minus 1 and then start from 0. So this becomes t, I open it up, so it becomes minus 1. So that is why I was a little bit suspicious to this calculation. Okay, let us see, hopefully it will work. And then what happens, because logically it should work. Yes. And then what? I start from 0. I will wait a little bit for you to digest what I have done. So you see, what I'm playing, this t is this t, and instead of this, I calculated the first term, which corresponds to minus 1, k minus 1, and then The rest of it starts from 0, yes? Do you agree? And then I copy and paste the last term. Okay, this might seem troublesome, but it is not. What is that? It's 1, yes? Because the n takes these values. If n takes these values, what is the probability of n greater than 1? It's just greater than -1, it's just simply 1. Okay, and I think we are done, so it worked. So this is 1. I multiply this t in. T times t inverse becomes 1. T multiplied by that and then I copy and paste the rest. Do you agree? And now what happens, this term is exactly that term, but this happens with t, so I can factor this term out. Are you okay with this? So this is a term, that is the same term, call it a, whatever you call it. I pull this out, and from this term t is left, from that one minus 1. Yes? And I hope that what I have calculated, I hope that you are not lost. I have started calculating g sub nt. I did the calculation, I reached here. So let me put, therefore, gn of t is this guy. Yes. So I want to have this, because I think for the next part you might need this in this form. But if this is just one more step, yes? Do you agree? I just move this to the other side. Equals to this multiplied by that, and I divide by this. This becomes sigma, k goes from 0 to infinity, t to the k, p, n greater than k. So that's the first point. And this is possible to divide because I'm on the safe side. This t is not 1 because of this assumption. Okay? That's the first part of the problem. Understand it? Okay, the next part of it is asking you to show that expectation value. So this is the second part. We want to show that the expectation value of n is exactly that sigma. And that is very, very simple now. And there is a theorem. If you have generating function if you have probability generating function of a non-negative discrete random variable, how can I find the expectation value of it? I don't know if you have seen it in the book. So what is En? En is just simply G prime of T. Oh, sorry, hold on. So that's why I need this one. So I calculate the derivative here. Of course, you know that for the 1, I might be a little bit in trouble, but I think even for 1, this series converges, yes? Yeah. Okay, but anyway, so let me take the derivative first. If I take the derivative here with respect to t, so this is the formula you need to know, okay? Or might be you can use the book if it is allowed in the exam, but this is you need to know. Do you know the generalization of that? If I have second derivative, what happens? If I calculate the second derivative at the same number 1, it becomes e of what? n times n minus 1. If I have the third derivative, it becomes e of n times n minus 1, n minus 2. There's a theorem, the proof is very simple. or you need to know one. Okay, but there's just to refresh your memory. What are the interpretations of list n? No, this one. If I'm talking about probability generating functions for non-negative discrete random variables, if you calculate the derivative at 0, it has something to do with the probability. If you take the derivative and calculate it at 1, it has something to do with the expectation. Okay? So if I want to, let me remind you, because these are important formulas. Okay? So if I have g, let us say kth derivative of any random variable, discrete non-negative. Okay, discrete non-negative at 1, this becomes expectation value of x multiplied by x minus 1, continued up to x minus k plus 1. Of course, on the condition that these things actually are filled full with yes. They are less than infinity. So look up the criterion. So there are some reasons that, of course, you want to have the series converged. Okay. So that's technically speaking, that is the case. And then you also have this scenario. So if you remember what this is, so g of k of that type of random variable are calculated as 0. This becomes k factorial multiplied by p probability that this random variable is equal to k. So that is why these are called probability generating functions, because its derivative have something to do with probabilities. Okay, so if I want to calculate expectation value of n, it means I am using this formula when k is 1. If k is 1, then this becomes the first derivative at 1, and this becomes simply expectation value of x itself. So what I have written here is the special case of this theorem for this random variable n. Okay, so if you don't want, let me start writing it here, because I want to take the derivative of that with respect to t first. So g prime of g prime sub nt is equal. If I take the derivative of this in the box with respect to t, the first one is 0. The second one is the derivative of the first one, because that's a product rule. Yes, it's the derivative of the first one multiplied by that series. The derivative of the first one is 1. So this becomes sigma k goes from 0 to infinity, t to power k, p n greater than k. And then plus the other way around, plus t minus 1, whatever that derivative is, doesn't matter. So let me just write it like this. Okay, and then I calculate g prime of 1. So En is equal to this. I plug 1 here instead of t. That's why I didn't do it, because this becomes 0 and that is gone. And this becomes sigma k goes from 0 to infinity, p n is greater than k. Is it the answer? Yes. Any questions? So, I don't know which problem we have to work today. First, let us start some problems from today's today, and then if we have time, we can combine. There is one problem that I didn't do it where I was doing it in the previous chapter. Might be that's a good problem if we can discuss, but it is very lengthy sometimes. Okay, so let me start with this problem. If I have the number right here, because it is exercise 5827. Yes. 5827. very simple one. So let us start with the simple one today. We are supposed, so this is given. And please check if I have done these numbers right, because I don't have the numbers, I have in different files. So e of x to the n is given to be 1 over n plus 1. And then I want to find the distribution of x. Okay, so we did something very similar yesterday. It's good to refresh your memory. So do you remember, if I have given you the moments, and this they haven't mentioned, but they mean for every natural number, I think so. It hasn't been expressed in the problem. I'm assuming that n is a natural number, any natural number. So then they have given me the moments, and I am supposed to find the distribution of that random variable. So what is the standard trick here? Do you remember what was it?
Moment generating function.
Moment generating function. And then we have this formula that I just did it yesterday on the board. So we have this. We can write it as what? 1 plus sigma. N starts from 1 to infinity. And then I have t to the n divided by n factorial. And then I have this expectation values of x to the power of n. This is very simple. I did it yesterday, so you can refer to those, or you can go to your book. So this is important. Have it in mind. If the moments are all given, and you are supposed to find the distribution, this is a good starting point. Okay, so then what should I do? You have enough experience of these things now. So this becomes 1 plus sigma. N goes from 1 to infinity. T to the n, n factorial. But this is given to me. It's 1 over n plus n for every natural number. You have a lot of experience now for manipulating and engineering these sums. So this becomes 1 plus sigma t to the n divided by what? N plus 1 times n factorial becomes n plus 1 factorial. But n goes from 1 to infinity. So, by the way, the reason that they put one separately, why do you think they put this one separately and make trouble for us? Because in principle, if I start from 0, what happens? If I put n equal to 0, this becomes 1, this becomes 1, e of 1 is 1, so that's 1. Why do they bother to separate this 1? Why do you think? Because if I wrote it in that way, this is a common mistake. They wanted to make that mistake for me. If I write this, it's a matter of confusion. Might be, if I ask you to calculate this, you answer 0. Because if I ask you to calculate this, you replace t with 0, and then you say 0 multiplied by everything is 0, so the sum of infinitely many zeros is also 0. But that's not the same thing. Yes? What is side of x0 is 1. Because the first term does not depend on t at all, so it's a separate one. So that might be the reason they want to write it separately so that you are not confused. But if you want to manipulate it, if you can see that what happens if I put 0 here, do you think it will generate this for me? If I put 0 here, this becomes t to power 0, which is 1, and this is 1 factorial 1, so that's correct. So I don't need to bother to start from, I can start from 0. Because usually starting from 0 is simpler to work with, yes? It doesn't matter, that is up to you what you want to do. But it is not a correct arrangement. Why? Because I know the sigma if these two are the same numbers. But this is n, this is, but you have a lot of experience now. What do you think I will do now? I will make it t to the power of n plus 1 divided by n plus 1 factorial. And of course I start from 0 to infinity. But what should I do to go back? I added 1 factor of t, so I have to divide by another factor of t. And why I can put it outside the sigma, I want to make sure that you understand. In principle, I have to put 1 over t inside the sigma, but 1 over t does not depend on the counter, so I can pull it out. So, but now, this one, what I can do, it is not the standard exponential function, but it has the right arrangement. Instead of n plus 1, what do I need to have? I need to have n. So this is also a standard trick we have learned a lot, we have done a lot. So I subtract 1 from these ends, but the price that I have to pay is to add 1 unit here. Do you agree? But then I have another problem, because that is not the standard exponential, because the standard exponential should start from 0, but that is also a very minor price. We can just pay it. Yeah? So what happens? I start from 0. And then how should I compensate for that starting? Subtract 1. I'm not saying this is the best way, but that's one way. I mean, as soon as you really know what you're doing, you can manipulate it in your own way. But then everyone knows about this. What is that? So then this means that psi x of t is equal to e to power, this is e to power t minus 1 divided by. Okay, so I don't have it in my memory, but I'm sure that this should be found in the back of your book. Yeah, so you have to go to the distributions. Anyone remembers anything about this? So if I go to the back of this, where is it? But of course, in the distributions, you have e to power it. Pretend that e to power, because they are talking about characteristic function. That doesn't matter. So you find it somewhere. Is it a uniform distribution or something? No. Did you find it? But if you want to go from here to the generating function, so you have to replace it with t, and that's the definition. And if I replace it with t here, that's exactly that. Okay? So this means that you can conclude you need to ask Lucas, are you allowed to use that, or you have to justify why this is the case. But in principle, this is the process, yes? This becomes 1 and 0 from the back of the table. But if you want, we can also do this one. How can I calculate this just as an extra practice? If I want to really calculate this myself, okay, so if this is the case, let me calculate this. Okay, how should I do that? What is the definition? Distribution. So it is continuous, so you have to write integral of e to power tx, and then f of xx, and then dx. On this from minus infinity to plus infinity, but because this is a uniform distribution of this interval, so it will be limited from 0 to 1, and this becomes 1. Okay, so that if you want to calculate this, and then you run it from 0 to 1. Yes, I'm going it fast because it is very simple calculation. And I don't think in the exam you have to justify why that is the case. You need to ask your answer. But that's enough. So you find this, and then you go to the table and see which one fits, and then you read the distribution. But remember this trick, please. Whenever you want to go from moments to distributions, this is the trick. Okay, so the next one, let us do it. This is problem 4712, yes? Okay, so 4712, they have mentioned that x has triangular distribution on this interval from -1 to 1. They have also mentioned, so you don't need to refer to the back of the table, they have translated it itself in the problem. They have told you that this is equal to 1 minus absolute value of x if absolute value of x is less than 1, 0 otherwise. Yes? This is given. And then you are supposed to calculate, show that so we want to show that this is the characteristic function. We want to show that this is equal to sine t divided by t over 2 to the power of 2. Okay, so this we didn't talk about. So in your book, the letters they are used is G, psi, and phi. Okay, the G for probability generating function, psi for moment generating function, and phi for characteristic function. And just motivate you a little bit. Why we went from here to here? Because here it only works for non-negative discrete ones. If we want to extend it, we extend it to moment generating function. Moment generating function is useful for every random variable, continuous, discontinuous, negative, positive. But I don't know, do you know why we have to extend a little bit? Just want to have this idea why we want to extend to a new one, because there are some distributions that doesn't have psi, doesn't have moment generating function. The most famous one is what? The Cauchy distribution. I don't remember the general one, but the Cauchy distribution, I have only 0, 1 in my head. So the probability this distribution is 1 over 1 over pi, 1 over 1 plus x squared, and x goes from minus infinity to infinity. Okay, so if I have this, for example, if I have this probability distribution, which is written on the board, this function, if I want to calculate psi, if I want to calculate, so let us not confuse, if I want to calculate psi x of t for this function, what should I write? I have to write e to the power of tx, and then because it goes from minus infinity to infinity, I have to write integral from minus infinity to infinity e to the power of t little x multiplied by this function. Okay, dx. Okay, and it turns out you can probably sit down and think, in any case, t positive or negative, this integral diverges. It doesn't matter what t you choose, this integral diverges. Okay, so that is one motivation to have in mind if someone asks you why we are moving forward, because yeah, it was good enough to be honest, but there are some distributions that probably are important and they does not converge. That is one motivation why we go forward. And then do you remember what is the definition of this? They are very similar. Okay, so what is phi of xt definition? It is e, the expectation value. Instead of having e to power tx as for psi, now you have e to power I tx.
It's a minus.
What?
It's a minus.
No, it's not minus. It is I. I is the imaginary unit. I squared is minus. Okay, so it means that in principle, if it works, you can write what? You can write psi x of t is psi, phi x of t is psi x of it. Something like that. So that is why they have given you only this one in the table. Wherever you see it, take it out and put t, you will get psi x. Okay, anyway, that's the definition. So, of course, it makes it harder. Why? Because all the integrals will be complex integrals. And I don't know how many, have you passed this complex analysis course or something? Have you seen Cauchy, Bursa theorems and things like that? Okay, so then I don't think, if you haven't seen that before and you're allowed to take this course, might be you really don't need to just trouble, you can look up in the table. Because calculating those integrals could be a little bit messy. But I will try to at least do my best. Don't sacrifice any rigor. But sometimes we have to, of course, and then we can discuss about why this is important. But let us start from here. So what I'm saying is that this is your definition. Okay? So first thing I do is, and then I do what? I will write the definition. And then I will put it in my I put the formula for the expectation. What is that? It is integral of e to power I t x, little x, and then I multiply it by what? By this function, dx. In principle, I have to run it from minus infinity to infinity, but because the support is only this part, this will vanish, only I consider this, and it limits my integral from -1 to 1, because this means between -1 and 1. So what happens? So this becomes integral from -1 to 1, e to the power of I t x, and then I have 1 minus absolute value of x dx. Yes, are you okay? But the point is that anyway, this integral is an integral in the complex variable analysis, because it is not a normal function, it's a complex function. But that one is not hard, yet, because in the lecture notes they are manipulating this as if it is normal exponent. Ask Lucas if that is okay with him as well, okay? Because conceptually they are different. But let me do it in a little bit rigorous way. Even if you study complex analysis course, it is not the definition of this kind of integral, which depends on a real variable, okay, is not what. You need to write a definition of this exponential. So this becomes what? You need to separate. That is the idea. The definition of this integral will allow you to separate this integral to its real part and its imaginary part. So if I have a function, a complex function, for example, if I have f equals to, I don't know, f of z is equal to alpha z plus I beta z. Okay, in the complex analysis, you will see that the definition of the integral is in a way that allows you to integrate them separately. Okay, let us not do that. So if I want to continue, hopefully you remember a formula. This is a very famous one. Complex numbers, you have even seen it in high school. What can I write instead of e to the power of itx? Euler formula. So it becomes cosine tx plus I sine tx. This is sitting for this part, and I copy and paste the rest. Okay? But now I have to break this integral to its real part and its imaginary part. So let us do it. And we can do it in our head. Yes, I multiply this by the first one, plus multiply this by the second one, and I separate the integrals into two integrals. So it becomes integral from -1 to 1, cosine tx, 1 minus absolute value of x, dx. So if you don't mind, let me put a small pair of brackets around here, so you're not confused. And then I have dx. And then I would write I is a constant, I pull it out, -1 to 1, and then I have sine tx, and then what happens? 1 minus absolute value of x dx. So, but is this a normal integral or not? It's an integral in real analysis. Yes, there is no I here. And this one is also a normal integral. So it means that you change the integral, the complex integral, into two real integrals. And then you calculate them as if you are doing integrals in the real. But I hope that you have enough experience, don't mess around a lot. Because whenever this is symmetric, you always need to ask one question: is there any way that I can use the parity? Parity means evenness or oddness of my function. Okay? For example, what do you think would happen here? If I change x to minus x, this will not be affected, but this will pick up a minus sign. So it means that this function is what? This function is odd, and this is symmetric. So the answer to this is just 0. Yes? But this one, what is this function now? If I change x to minus x, it doesn't change, but cosine also absorbs the minus sign. It doesn't change. So this is even. It makes the calculations a little bit simpler. So instead of going from -1 to 1, what can I do? I can go from 0 to 1, but the price is to multiply by 2. So it becomes cosine. This also has another benefit. And then 1 minus absolute value of x dx. And then it allows you to also remove the absolute value sign. Because this one, x is positive, so I don't need absolute values. Yes? So I have to calculate this integral. Okay, so what should I do here? Do you know what to do? So let me change, because yesterday I confused some of you. So let me write it in the proper way. So I would write it. In principle, you should really know what is the technique to calculate this integral. Do you know that? No? No clue. Integration by parts. Yes, that's a good choice. Integration by parts. I have the American version in my head. I don't know if you have studied the Swedish book or not. Have you studied calculus for atoms? A complete course? Yes? Well, how is that possible? I remember what I read 30 years ago. Yes? So anyway, uv minus integral vd. Yes? This is u dv, uv minus integral v du. And if I have the definite version of it, then I have the definite version of it here as well. So let me, if you forgotten, let me also give you a little bit brief idea. So which one to take u, which one to take dv is problematic. Sometimes one works, the other one does not work, so you have to have enough experience. Putting my experience in the problem, I will take this one u, and I will take the rest dv. Okay? And then let us do that. In order to, now that this integral is integral of u dv, I want to write it. So I need u, I have it. I also need v. Okay? So dv is cosine tx dx. So can you tell me what is v then? V is integral of this, because dv is this. V is integral of this, which is 1 over t sine tx. And then, if u is this guy, on the right hand side of the formula, I need du as well, so it motivates me to calculate du, which is minus dx. Okay, so and I put now everything here. So I have a 2 here, so let me write 2, and I open a pair of brackets, and then I'm using the formula u times v. This is my u, this is my v. When I multiply them, what will happen? It becomes 1 minus x over t, and then I have sine tx, and then I have to run it from a to b, in this case from 0 to 1, minus integral from 0 to 1 again, what v du. This is my v, this is my du. Du has a minus sign, which makes this positive. And 1 over t is a constant, because my integration variable is x. I can pull it out from the integral, and I am left with sine tx, and then I have dx. Are you with me or not? Understandable? Just plug it back into the floor. Okay, so let us calculate this here. Okay, so this is very simple. Be careful, your variable is x, not t. So you replace x with the upper limit, vanishes. You replace x with the lower limit, it also vanishes or not? What? That is very strange. Yes, it vanishes. I cannot do anything. So if I put 1 here, it is gone. If I put 0 here, this is gone. Okay, so that's 0. So it is 2 times 0. But this one, what should I do? The primitive function for this is minus 1 over t. There is another t here, so it's 1 over t squared. And then I have cosine t x. Again, I have to run it from 0 to 1. So what happens now? So this becomes, I multiply 2 in, so it becomes minus 2t squared. What should I do? I have to replace x with the upper limit, so it becomes cosine t, minus, I have to replace x with the lower limit, cosine of 0 is 1. And if I multiply the minus sign in, so it becomes 2t squared, and then I have 1 minus cosine t. So that is my calculation. But I have to manipulate it a little bit, because this is the answer given in the problem. I hope that you can see it immediately. Do you know the formula for this? It's a very famous combination, yes? So what is the formula for this? It is 2 sine squared of half of the angle. Okay? So then you see that it is done. because this becomes equal to the 2t squared multiplied by 2 sine t squared to the power of 2. I hope that you agree that's the same combination written in the problem. Yes, do you agree? Yes, because this one squared gives me, that's correct. This one squared gives me a t squared in the denominator, that's correct. This one squared gives me a 4, which will go to the numerator, and that is my 4. So everything is okay. So that is the calculation. Any questions here? You need a break or not? Yes? Okay, 5 minutes. Two random variables, uniformly distributed, both of them, and it is mentioned that they are independent. And you want to calculate the distribution of x1 plus x2. But of course you know that you could even in the lesson, the first week you could do this problem, yes, without this trig. The whole point is that this is repeated in this chapter again because we want to change the strategy into a more efficient. And that is the idea of moment generating function. Okay? In principle, if you want to review, you can go backward and then solve this problem, as a problem in the previous chapters. It's very simple, yes? But let us do it in this way. So do you remember what is the technique if I really want to use the, first of all, forget about probability distribution, the generating function, because these are continuous variables. So this means that if I want to solve this, I need to solve it using moment generating functions for that. And you know that whenever they ask you about the distribution of anything and you want any random variable and you want to find its distribution, the idea is to calculate psi of that random variable. So this is a matter of seconds. You need to know this is a technique, you should have it in your toolbox and know this. But the notion of independence is necessary, otherwise this will not be that helpful. Okay? If there is a theorem, if x1 and x2 are independent, by the way, it's not a very hard thing to understand, yes? But I want you to know, if they are independent, you can write it as x1t multiplied by x2t. Yes, psi sub x1, t psi sub x2t. Okay? If x1 and x2 are independent. If not, there's only one way. We have to go backward and solve it from the previous steps. So, and then it means that, okay, I need to calculate this for the uniform distribution. I don't know, might be you're allowed to read it from the table. You remember what was it? We calculated once. So both x1 and x2 having the same uniform distribution. So in principle, what it means? It means it's better to write it in this way. Because they are the same functions, and if you don't mind, let me bring x in. X is a representative for both of them, so it means that this will be this function to power 2, where x is this uniform distribution. That's a good way to write it down, okay? Because they are the same, they have the same distribution, these two functions will be identical, so whatever this is the same thing, so I write that into power 2, but then I say that where is x this one? So do you remember what was it? So if otherwise I have to calculate this, so let us do it here. So this becomes e to the power of e to power tx. So this becomes integral from -1/2 to 1/2. Then I have e to power tx. And then what is that? This one minus that one, yes? So it is 1 over this one. Equals. Yes. So what happens now? So this becomes 1 over t e to the power of 2x. Then I have to run it from -1/2 to 1/2. So this becomes e to the power of t 2 over 2 minus e to the power of minus t over 2 divided by t. Am I doing some mistake? Is that right? Okay. So let me double check, because this means what? This means that f of x is equal to 1 over this minus that, which is 1, so that is just 1, if x is between minus and half, so that's correct. So sure. 0 otherwise. So I put this in this formula, so that's why you don't see anything here. It's 1, and I run it from here, and this is the function. I put the number, that is it. Okay? And then I raise it to power 2, because I want to put it here now. So what happens? It becomes e t over 2 minus e t divided by 2 to the power of 2. Okay, because I don't have it in my memory, I don't know, I need to look up the tables. Do you see something like this in the table? But of course you might see IT here, IT here. Is there anything like that? Can you help me? Don't freeze, please. Do something here. So, where should I even look for? Yeah, I think it's another yeah. So, because when I see the table, the first one, for U, A, and B, for U and A and B, phi x of t in the table of the book is written to be what? E to the power of ITB minus e to the power of ITA divided by ITB minus A. Okay? But can you tell me how can I go to psi x now? I replace IT's with t. So this becomes e to the power of TB minus e to the power of TA divided by TB minus A. Do you agree? So by the information in the back of the book, I see that this is the case. So now this is my, in my problem, A is what? Minus a half. B is a half. So do you agree this will generate this one exactly? This one, of course this one. Then let me raise it to power 2. That's not power 2, unfortunately. I don't see any other one in this. Ah, yes, there is a power 2. There is a triangular one. No, I wrote the wrong one. So this is not working. Okay. So you need to write the triangular one. For the triangular one, so let me write it from my laptop. For the triangular one, you have this. For the triangular one, this one is e to the power of ITB over 2 minus e to the power of ITA over 2 divided by 1/2 there, unfortunately, I don't know why. 1/2 IT B minus A to the power of 2. Okay? So, if I want to go to psi now, what I have to do, I have to change IT to T. And now I put my numbers here. So this is 1/2. Yes. Okay, so we have to fix it somehow. This is e to the power of t over 4 minus e to the power of minus t over 4 divided by 1/2 t to power 2. This is not a good choice. I have to change it because I don't want to have t over 4. I want to have t over 2. So what should I change it? I change b to 1. Okay, sorry. Now you see, this is the general formula that you will find for the triangular distribution. But I want to adjust it, engineer it so that it matches with what I have. Okay. So what should I choose for B and A? To make this match with mine, I have to choose A and B both equal to 1. If I choose A equals to B equals to 1, well, that's also a problem.
Shouldn't A be minus 1?
Yeah.
What?
B should be 1 and A should be minus 1, yeah.
Yes, you're right. Yes. Very good. So A, B should be 1, A should be minus 1. If A is 1, yes, you are right. So then this becomes t over 2 2. This becomes minus t over 2, which is the same. I have the power of 2, that's also correct. Then 1 over 2 is the same, but this becomes a 2. Yes, that's correct. So you see, this one, I read it from the back of the table. It was the closest formula to what I got. And then that is up to me to engineer these A and B so that this function becomes exactly what I got. Then you help me to find A minus 1 and B1. If I plug A and B, these numbers here, I will get exactly 1. So yes, if I want to answer the final problem, what will it be? X1 plus x2 is what? Triangular of A and B. A is the smaller one, B is the bigger one. So it becomes, yes, A is the smaller one. So it's minus 1 and 2. So that is the final answer to this problem. Okay, sorry for the confusion a little bit, but are you following what I have done? So we calculate this by the product. If it is independent, this method will work. And then you just do the calculations as usual and get a function. Then you need to look in the table and see which one of the formulas in the table looks very similar to what you got, but it is not finished yet. You have to engineer the parameters of the formula so that it matches exactly with what you get. And this will give you the distribution. Is that clear? Okay. Okay, so there are some other problems. So this problem is, if I read it correctly, it is problem 6 part A. 4, 7, 1, 6 part A. Okay, and then what do I have? So we have x1, x2, up to xn, independent. Yes, this is given. And all of them are Cauchy distributed. So let me write collectively. All of these, all, are Cauchy distributed. Yes. And then we want to show that this random variable 1 over n Sn is also Cauchy distributed. If I ask what is Sn, Sn is the sum of these. Okay? So that's the problem. They have given me n independent variables. All of them are Cauchy distributed. We want to prove that this new random variable, in which Sn is the sum of all of them, in somehow it is the average random variable, is also Cauchy distributed. So how should we prove that? Okay, first of all, what is the translation of this? You need to look it up in your table. Yes, I told you in the beginning. So this means f of x is equal to 1 over pi, 1 over 1 plus x squared, if x is real. This is the meaning of this sentence. All of these are distributed in this form. Okay? That's the Cauchy distribution with parameters 1 and 0. Okay, so now hopefully you know what to do. What I'm supposed to do, I want to calculate the distribution. I want to know the distribution of this, so I will start with psi of 1 over n. No, can I start with psi? No, because you know that this is the famous one, so I have to start with phi. So I need to calculate phi of 1 over n Sn, and I have to calculate it to see what happens. So how should I calculate this? So first of all, can you tell me what should I do with this n, with 1 over n? Because that's a fixed number. Yes, if this was not there, I have a similar theorem for characteristic functions as well. So if 1 over n was not there, I could have written it as phi of x1 times phi of x2, etc. But first of all, what can I do with this 1 over n? Yes?
Can you move it inside of it?
Do you know why? Okay, so yes, that's not very hard. So if I have phi of a times x plus b, so that's a generic thing I want to say. And if you want to calculate this, in principle, what does it mean? It means e, expectation value of e to the power of I t times your random variable ax plus b. Yes? So then it becomes e. I multiply this in, it becomes a I t x, and then it becomes e to the power of I t b. Yes? If you multiply this in and decompose them, it becomes like that. But that's a constant. I can pull it out from the expectation value. And then what is left for me is e to the power of I t x. Yes? That's the definition. And I have separated them because this is a constant, does not depend on my random variable. I pull it out, but that is left. So this means that it becomes e to power I t b. But what can I write for phi here? Of course, this is not phi of t, but it is phi of a t. Yes? So this is phi of a t. Okay, so that's also a theorem in your book. That is also working for psi. But for psi, I do not have this I, of course. Okay? So this means that if I want to calculate this, as you told me, what I can write, so I want to compare 1 over n with a, Sn with x, and 0 with b. So if b is 0, this is just 1. So I can write it as phi of my random variable Sn, but I have to calculate it at at t. But what is a? Yes? So that's the first thing I will do. But in order to calculate a function at a different argument, I need to know the function itself. So what I will do, I will ask myself, what is phi of Sn of t? Because if I know this as a function of t, and I can replace t with that thing, 1 over nt, and I am done. So in order to answer that question, I start from here. But this is a standard problem. Now Sn is the sum of independent random variables. So I can write it as what? So let me write it in this way in front of your eyes. I have replaced this with that. But then, because they are independent, I am allowed to multiply them instead of adding them. Yes? But all of them are of the same type. So if you don't mind, let me write it collectively as phi of 1x t, and then I have it to the power of n. And then you need to introduce what x is. X has the same distribution. Yes? But this one is a tricky. I don't know, have you seen it in the course or not? Because this really needs a complex integration. So if you calculate this for this, the answer becomes, have you seen that? Because if you haven't seen complex analysis, there is no point for me, because this have to be counter integration. So the answer will be e to the power of minus absolute value of t. So please ask, because in principle, what should I do? In principle, if I want to calculate this, what should I do? I have to write a definition, itx. But then this means integral, because you see that it belongs to R. So I have to go from minus infinity to infinity, and then I have to write e to the power of itx multiplied by 1 over pi, 1 over 1 plus x squared dx. Even though technically speaking, I can use the Euler formula again, but then I will get two real integrals, that those real integrals cannot be used as just normal real analysis. You have to go to counter integration in order to be able to solve this. So this is not possible if I want to explain it without complex analysis. But you have to trust me on that. If you do the calculations, then you will get e to the power of minus absolute value of t. Okay? So this is something we cannot do. Of course, if you want, we can discuss about why later, but this you need to trust me on that. So that is it. And then what happens, so this means that I can continue here. So this becomes equal to this expression to power n. Independent Cauchy distributed random variables. So let me write what do I mean. I have x1, I have x2, I have x3. Yes. So, and all of them are Cauchy distributed and independent. Yes. And then they have defined again Sn for any n to be the sum of the first n terms. This is the partial sum. Yes. And then we want to show that this new random variable to n is also Cauchy. So let me give you a little bit of time to digest the problem. So is that clear? So I have a sequence of Cauchy distributed random variables. All of them are independent. I define Sn as a partial sum, the sum of the first n terms. And then I make up a new random variable in this way. So if you want to have a better understanding, what does it mean? It means that you have 1 over n. What do you have? You have the average between these new random variables. Okay, so for example, the first one is S1 over 1, the second one is S2 over 2, the next one is S3 over 3, and then you continue this list, which is Sn over n. This is a new random variable. So I have these random variables, I generate new random variables, put them here, and I generate even a new random variable. And I want to convince myself that this is distributed the same. So one question, do you think I can immediately use this theorem? So because that's also a sum, yes? And then you know that this is just a factor. So that factor doesn't impose any real serious problem because I can put it there. So forget about that factor. But then I have, so in my head, can I call this y1, for example, I'm just asking you, and I call this y2, and then I continue and I call this yn. So technically speaking, this is the sum of some random variables. Is it okay if I write y phi of this sum is equal to the product of these phis? Because that is, sometimes it is plausible, seems plausible, you might immediately start doing it. It's not very wrong, but why it doesn't work here? Who said no? Do you have a reason why it doesn't work? Do you understand why it should be plausible? Because you know that this 1 over n, we could solve it, that's not a big problem, so forget about this. But this is a random variable, yes? I call it y1, the next one I call it y2, y3 up to yn. And then what do I have? In principle, I have the sum of some random variables, and I am interested to know its distribution. So it is natural to calculate the characteristic function of this. And this seems plausible to write that. Is that okay? Yes or no? If you're saying no, you have to defend. They are not dependent, yes? They are not independent. Even though x1, x2, x3 are independent, but there is no guarantee that s1 and s2 are independent, because s1 is just x1, but x2 is x1 plus x2. So So there is no guarantee that these random variables are independent. So that's the hard part of the problem. So I cannot use this because even though they are independent, there is no guarantee that these are independent. So don't use this. Okay, do you have any idea then what to do? Because the information about independence is for x's, so it is natural to express them in terms of x's, so that I can use its independence. But then I don't know how I can use double sums, but I think I prefer to do some simple algebra. So if I call this one a new variable y, for example, so let me write this as y is equal to 1 over n. S1 is just simply x1 over 1. What is S2? x1 plus x2 over 2. And then x1 plus x2 plus x3 divided by 3. And then plus, at the end, I have x1 plus x2. Of course, you can use double sigmas, but there is something you need to know, otherwise you can. Okay. So I have just written the names, but do you see that this is good? Because now I can rearrange this as a linear combination of only x1, x2 up to xn. And I know that x1 up to xn are independent. Okay? So then I can use it. But this is a little bit just simple algebra. Can you see what is happening? x1 appears in how many places? In all of them. But first one with coefficient 1, the second one with coefficient 1/2, 1/3, up to 1 over n. So it becomes 1 plus 1 over 2 plus what? 1 over n x2. Yes? Do you agree that? But what happens for x2? x2 does not appear in the first one, it appears in the second one, the third one, and etc. So can you tell me what will be the coefficient of x2? It doesn't start from 1, it starts from 1/2, so it goes 1/2 plus up to 1 over n. Yes? And then I can go forward, and let me just write the last one. So what do you think will be the last term? 1 over n xn. Yes? Is that right? So this one is exactly like this. Okay, so if you don't mind, let me write some simple notations. If you don't mind, let me call this one A1. A1, I start with 1. Let me call this one A2. That's a constant. Okay? And then let me call this AN. For just simplicity of writing, I'm just bringing some notations in. So it's 1 over n, A1 x1 plus A2 x2, and then it continues plus AN xn. Do you agree? So that's it, but these are A1. So now I think it will be a little bit simpler, but now I can use that theorem that I couldn't use before, because now if x1, x2, and xn are independent, A1, A2, AN are constants, so these random variables are still independent. Okay, that's different from the previous story. Okay, so now if I want to calculate phi of y, yes, what should I do? Phi of y of t is equal to, it is 1 over this combination. So it becomes phi 1 over that combination. Okay, at t. The first thing I do, I will get rid of this by moving it inside, yes? But then I can do what? Can I now separate them and multiply them? Because x1s up to xn, they are independent. By multiplying by constant, independence doesn't change. So what happens here? It becomes phi of a1 x1 calculated at 1 over nt multiplied by phi an xn calculated at 1 over nt. Do you agree? Everything clear? Okay, but then can you tell me what to do again? Again, you have this nasty coefficient. What should I do? But you know what to do, yes? Again, you shift it inside. So what happens now? This becomes 5x1. It becomes a1 over n. And then you have t. And then you continue until 5xn. You have an over n. But what can I write this? You remember, all of them are Cauchy distributed. So I just didn't calculate, but I told you that 5x, if x is Cauchy, is e to power minus t, yes? But this is the general formula. But here, I have to replace t with this combination for the first one, up to this for the last one. So what happens? This becomes e. Can you help me to write something here? What should I write? This is phi of t for Cauchy distribution. All of them are Cauchy distributed. So what can I write for the first one? Minus absolute value of a1 over n t. Is that understandable? Because this is phi of x1 t is e to power minus absolute value of t. I want to calculate this, so I have to replace this t with that combination. And the next one is e. Okay, the next one I haven't written it here, but you know what it is. It is a2 over nt, and this will continue until I reach to the end. Yes? But now, this is just a very simple calculation because this becomes e, and this will be added together. But all of them are positive constants, so if you don't mind, let me pull them out. So it becomes minus a1n absolute value of t minus a2n absolute value of t minus up to minus an over n absolute value of t. But then I can factor minus absolute value t out. So it becomes a1 over n plus a2 over n plus up to an over n absolute value of t. I can do a little better. So I can factor, I forgot to factor 1 over n out. So it becomes minus 1 over n. And what is that? a1 plus a2 plus up to an. And then you have absolute. Yes. We are done. The only thing that is left is to calculate this sum, if there is something good in it. Yes? Because we know what the answer should be. What do you expect for the answer? If the question designed correctly, the answer should be e to the power of minus absolute value t, simple as that. But is it? Let us go back. What was a1? So I have to add a1, a2, up to an. When I start adding them up, okay, 1 appears in how many places? I want to add them up. 1 appears in one place. So when I add them up, I will get 1. But 1 appears here, and the next one, but not the third one, not the fourth one. Do you agree? Because the third one starts from 1/3. The fourth one starts from 1 over 4. So 1 over 2 is here and there only. When I add them, it becomes 1 again. Yes? What about 1/3? 1/3 is not here. Is not here. It starts from, sorry. So 1/3 is here, here, and the third one, not the fourth one, etc. So 1 over 3 plus 1 over 3 plus 1 over 3 is again 1. And then if you continue this list, where 1 over n appears? In all of them. In n of them. So it becomes again 1. So that sum is what? I hope that I could convince you. So then it becomes e to power minus this. Yes? Is that clear? But I want you to feel that you have to do it, because you know, if that was, to be honest, I started calculating it wrongly first, then I realized what's going on. The reason is that I didn't care about that they are not independent. So if you want to use the formula, you have to make sure that they are independent. And if they are independent, then you can use them. But I didn't see, I see that this is not independent, so what do I have? I have independence about x1s, then it becomes natural to write this in terms of x's rather than other variables. Then the simple algebra will solve. Any questions? So I hope that we have time to go to the next one. The next one, I think, I'm not sure even if I understand it very well now. So this is problem. If I am right, it is 4.7.2.1 here. So let me write it quickly. If I have random variables, they are IDs, x1, x2, up to continuous. These are IIDs, independent and identically distributed. But they haven't mentioned anything about them. But all of them are discrete. So P of any x from this list, it can take value -1 with probability 1/4, 0 with probability 1/2, and 1 with probability 1/4 again, but 0 otherwise. Okay? And then they have defined a new random variable, n is defined to be the minimum of these little n's for which xn takes 0 value. In other words, n is the smallest or the first n such that x sub n is equal to 0. Because from here you know that if I ask you what are the possible values for x1, -1, 0, and 1. Yes, these are the only possible values for each one of these random variables. They are IIDs, and then I define n to the minimum of this list. For example, if you look at this list, what you might expect -1, 0, or 1 in these places. There is a place that 0 appears for the first time. N is that. N is the location of that, the position of that first. Okay. And then this is a little bit, this is easy. You want to show that n has this distribution, fs 1/2. What is fs? Is first success. So again, you have to check it, what is first success. But let me just calculate this probability distribution and then check it with the answer with the table at the end of it. So how should I understand that? I want to know that this random variable defined in this way, the first time, the first location at which this sequence hits 0. That is the meaning of this n. And you want to show that the distribution of this random variable, it is a random variable because they are taking values randomly, so that's also a random variable. We want to show that its distribution is the first success with parameter 1/2. Okay? So how should I do that? Forget about the name of the distribution. We find it and then we check it with the formula in the end of the year. So if I want to find the distribution, hopefully you agree with me, n is discrete. So this means that I have to calculate n. If you don't mind, let me change it to k. So what is the meaning of this? Let me write little p. This means that probability of n becomes equal to k. Yes? And they are all independent, so be careful. So what is the meaning of this? It means that, what is the probability that the first time that this takes 0 is the kth time? So what does it mean? So can you tell me what is the meaning of n equals to k? This is equivalent to saying what? The first time that I see 0 in my list is the kth place. This happens if and only if what? x1 is what? x1 is not 0. Yes? x2 is not 0. xk minus 1 is not 0. But xk is 0. Yes, that's the meaning. N is the minimum number that you see 0 in your list. Minimum place, minimum location. But you want to have the minimum location, the kth location. If this is going to happen, it means that in no other locations previous to kth location you have 0, so none of them is 0, but the last one is 0. That's the mean. Do you agree with me? Okay, but now can you tell me what's the probability? So this means the probability of x1 not equal to 0 multiplied by the probability of x2 not equal to 0 because they are independent up to probability of xk minus 1 is not equal to 0 multiplied by the probability that xk is equal to 0. Yes? But the probability of x1 not equal to 0 is 1 minus the probability of x1 to be 0. So let us do it in our head to save time. So what's the probability of this one? To be 0 is 1/2. Not to be 0 is also 1/2. So this becomes 1/2 multiplied by 1/2 multiplied by 1/2 k minus 1 times. But multiplied by the probability of the last one b0, which is again 1/2. So this becomes 1/2 to power k. And that's exactly this probability distribution. If you look at the back of the table, you will see that this means that n is first success. Yes. So I will continue until this probably finishes, but you can feel free actually if you want to do it. The second part, I think that the last part might be I will ignore, but the second one is a little bit even still problematic for me. So let us see what the problem is.